is on probability and odds. When we talk about probability, we're talking about the likelihood that something will happen. When we talk about odds, we're talking about how likely it is that something will or won't happen. Now for this lesson, as you can see, we have 6 different vocabulary words. It's a lot more than usual. In isolation, these might be a little hard to follow, but as we work through our 4 examples today, they will become more clear. Our first word is outcome. When we're talking about probability and odds, the outcome is the result of an experiment or a test. Number 2, our next word is event. And when we use the word event in this context, we're talking about a specific occurrence, basically what you want to happen, what you're looking for. Our third term for this lesson is favorable outcomes. Favorable means the possibilities of achieving the event, all the chances that we have of getting what we want in our results. The word probability is the likelihood that an event will occur. Now when we talk about probability, we have 2 different kinds. Number 5 is theoretical probability. In theoretical probability, it's based on knowing all of the equally likely outcomes of an experiment. And then number 6, experimental probability, that's based on repeated trials of an experiment. And this is more typically used for making predictions. Now when we talk about theoretical and experimental probability, we have 2 different formulas that we need to keep in mind. When we are trying to figure out the theoretical probability of something happening, what we have here is the P of the event, so the probability of our event. And in this fraction, our numerator is the number of favorable outcomes that we have, and our denominator is the number of possible outcomes, both favorable and unfavorable. But when we talk about experimental probability, again, our probability of the events, this is more about the successes versus the trial. So how many times we have achieved our outcome over the number of trials we've attempted. So now what we're going to do is start working through our 4 examples. Here's our first. You have a number cube. What is the probability that you will roll an odd number? So here's an example where we are going to use a formula for theoretical probability. Just to remind you of what that is, our event is rolling an odd number, and our formula is going to be the number of favorable outcomes over the number of possible outcomes. Now, an odd number, you know that on a number cube, the numbers are 1 to 6, which means that there are 3 odd numbers. So we could get either a 1, a 3, or a 5. We have 3 chances of getting our desired outcome. Our denominator is the number of possible outcomes. We have to include the even numbers too. So that means there are 6 possible numbers that we can get every time we roll a die. If the probability is 3 out of 6, we take that fraction and as always we simplify, and that becomes 1 over 2. So the probability that you will roll an odd number on a number cube is 1 out of 2. Let's take a look at our second example. In our second example, we are going to use the experimental probability formula. Let's listen to the problem. You asked 24 randomly chosen people what their favorite season is, and 15 of them said spring. What is the probability that the next person you ask will also choose spring? So remember what I said about how experimental probability is used for making predictions. Here's a good example of that. Let's just fill in the pieces to our formula. When we talk about experimental probability, our numerator is the number of successes. We were looking for how many people what is the likelihood the next person will say spring. Those are our successes. 15 people said spring. out of the 24 people asked in this survey. That's the total number of trials. 15 over 24 is not in its simplest form. Both the numerator and denominator can be divided by 3. 15 divided by 3 is 5. 24 divided by 3 is 8. So the probability of someone saying spring is 5/8. We're going to use experimental probability for this next problem as well, but there's going to be an extra step. Let's look at number 3. You bowled 30 balls and got 18 strikes. How many strikes will you probably get tomorrow if you bowl 45 balls? Again, experimental. Probability means we take our number of successes over our total number of trials, and of course, you know in bowling a success is a strike. So when we went bowling today, we got 18 strikes out of 30 balls bowled. But now we're being asked a different question than we were asked in number 2. We don't want to just know what the probability is. We want to know that based on this probability, on this ratio, how many strikes will I probably get if I bowl 45 bowls? So we're looking for how many strikes I will probably get of the 45 balls that I bowl. What we do here is we practice our cross multiplying, which means we have 18 times 45 equals 30 times x. 18 times 45 equals 810. 30 times x is 30x. And we want the x by itself, so we have to divide both sides by the coefficient 30. And when we do that, we find that when you bowl 45 balls, you will probably get 27 strikes. And we have one more example before we conclude. And this is a little different from what we have been doing so far in this lesson. You notice the title of the lesson is Probability and Odds. And our first 3 examples were all about probability. Now we're finally up to odds. And you know the odds of something happening is the chances. When we talk about odds, we talk about the chances that something will happen. Well, sometimes we're asked the odds that something will happen, the odds in favor of something. And we set up our fraction a little differently. Our numerator, when we want to know the odds of something happening, is our number of our favorable outcomes over the number of unfavorable outcomes. And when we're being asked what are the odds against an event occurring, we just switch the numerator and the denominator. Here, what we do is we divide the unfavorable outcomes by the favorable outcomes. And when we write our final answer, we don't keep it in fraction form, we use the word 2. So we write it as the numerator to the denominator. That's how we write odds. Now to our last example. You have a spinner numbered 1 to 8. What are the odds that you will land on a prime number? Now we want to know the odds that we will land on a prime number, so we are looking at our favorable outcomes versus our unfavorable outcomes. We talk about the prime numbers between 1 and 8. There are 4 of them. 1, 2, 3, there are 5. 1, 2, 3, 5, and 7. That means we have 5 favorable outcomes. And our denominator is going to be the remaining numbers that are composites. So between 1 and 8, those numbers are 4, 6, and 8. So the odds of spinning a prime number on a spinner that is numbered 1 to 8 are 5, 2, 3. It's a lot of work in this lesson, a lot of reading, a lot of reviewing, but I know you can do it.